Hello everyone and welcome to the demonstration video. In this video we're going to do an introduction to what we call object-oriented programming. We also consider it short, but you'll just hear me call it object-oriented programming. Just know, again, this acronym is what we're referring to. Okay, so when it comes to object-oriented programming, again, this is going to be an introduction, so I'm just going to show you the layout of the base components when it comes to this concept. But basically the idea of this, so this is a type of programming, so you could just call this this is a specific type of programming in which typically when we program we have some kind of problem to solve. A lot of the programs you have been working on is smaller algorithms, which is, for a small application. You've done stuff like just a mini replication of a storefront, some calculations, kind of like a math calculator. So all of those implementations were actually very simple versions of algorithms. If you want to expand it further, for instance, that one program with the store and you're getting the person's order and then doing a total with it, that can be expanded with object-oriented programming. So again, the whole idea of that single algorithm, well, one, of course, to teach you the core concepts of Java, but two, expand a little further. If you had a store, okay, so you have some kind of store. Let's go ahead and let me start drawing this out. So you'll have a store, and I want you to take some time to consider what is the different parts of a store. So you could go ahead and create a list, just jot down different things that are part of a store. What components make a store a store? Okay, and if you are back, let's go over things you could see in the store. So typically you have some kind of stuff you're selling. Maybe this is a grocery store, so we have produce, so maybe we are specifically selling produce here. Maybe we're selling some kind of meat. So I forget the word we would use for that, but I'm just going to call it meat. You may have other things as well as what you're selling, which is overall known as products. But also other things that are part of a store are your employees. I'm going to put emp for short. You have your employees, different kinds of employees, and you even have your customers. So these are the main things that can make up a store. You could keep on adding on to this, whether that's the actual aisles themselves, the refrigerators, cash registers, but just the general sense of the store is, hey, we are selling products to people, and there's people selling those products. So again, you have more of your products, so produce and meat, you have employees, and then you have customers. Now, this little practice that we just did is basically the whole idea of object-oriented programming. You're not just going ahead and creating an entire algorithm with a bunch of different variables for produce and meat, employees and customers. What we're doing in the process of object-oriented programming is identifying what are the main parts of our problem. So in this case, you could think of this as creating some kind of application for managing a store. So if you've ever worked in, let's say, other stores before, you have some kind of system in which you keep track of inventory. So what kind of items do you have? How much do you have of each? Notice when you go into a job, you also have information related to you as an employee. So there's information about you, obviously your name, maybe some kind of birth date, your salary will be there, even your employee ID. So there is some information related to you. And especially if you have a store that has rewards, so rewards programs, you have to sign up for them, you'll have information about customers. And especially if you're doing online orders, that's going to be bundled up with a customer. So notice that each of these these are kind of different abstract ideas that we've broken this problem down into. So we want to create an application for managing a store. These are the different parts of a store. So all of this is what we consider different objects that make up our problem. There we go. So an object is any set of related data or behaviors for an entity that you've broken the problem down into. So in the case of a store, the store is an object itself. It's an entity that holds all of these other entities. So you have different produce, you have different meats, employees, and you have customers. And in each of these objects also have data related to them. So in the case of this demonstration, I'm just going to keep it simple to a single object. So let's focus on the employee. Employee is a little easier for people to understand. Okay. So if we're representing employee as a single object, so this is an entity, a set of related data and behaviors, go ahead and take a moment to think about different things that make up an employee. So if you had to store information about an employee, or even certain behaviors related to an employee, what would that be? So go ahead and give yourself a moment to jot that down. And if you're back, welcome back. Let's take a look. So when it comes to an employee, again, I mentioned there's different things to them, like the name. There we go. Usually employees have some kind of ID related to them, whether that's for a badge, for verification, so they will have some kind of ID number. Typically, you have some kind of salary associated to the employee. There we go. So they have some kind of salary, whether that's hourly, monthly. Typically for a store, it's hourly. Maybe you want to store their position. So what kind of position are they? Are they a cashier? Are they a stalker? Are they both? Are they a manager? So there's different kinds of employees we could think of. So this different data that we think of for relating to an employee is what we know as an attribute. All right. So an attribute, you could also think of it as different properties that relate to your object. So again, the object itself is the collection of data for this entity. An attribute is any individual property related to it. So you have different attributes to an employee. It could be a name, ID, salary, position. If you want to add more data about them, you would add in more attributes. And notice this is starting to sound a lot like variables. So different attributes can be considered variables. So this says var, but excuse my writing. There we go. Attributes can also be, let me choose a different color, or not necessarily attributes, but other things you could relate to this employee entity are operations. So remember I told you to jot down some things about that could relate to an employee. You may have come up with stuff like this, data. But if you want to give yourself a moment to think about different functions related to the employee, go ahead and jot that down. If you've already done so, you could go ahead up and watch this portion. So I'll give a moment for those people jotting down. Okay, now different things that are associated to an employee. It could be maybe they need to change their name. So you could put in change, and I'm going to put N for name. Maybe you need to increase their salary. So let's just call this Inc. Sal for increasing salary. Maybe something associated to the employee is something like putting them to work. Oh, not a good pen. There we go. So notice there's different operations that you could do to the employee. Again, they could change their name, their salary can be increased, or you could put them to work. They could actually go ahead and work. So these are known as different operations, just related to the class. So you could just think of these as operations, functions. but they are specifically related to this object. Let me go ahead and encompass this so you could further get an idea. So all of these is what makes up a single entity employee, and we've broken it down to different attributes related to them, different operations. Notice that if we did the same thing for, let's say, some kind of product, we would have a different set of data. Not all products have a specific salary. You can't give money to a product. And if you want to put a product to work, you can't necessarily do that, but you can do things like sell or buy them. But this is the idea of breaking an entity within your problem down into an object. So again, this is an entire employee object, a set of data that relates to each other. And we go about this by giving them different attributes and different operations. So this is what we considered an object. Now, more specifically, what we just did right now, so an object is, you could think of it as an entity that's existing. So if I gave these values to each of these attributes, that would be a singular object. So you could think of it as something that exists. What we just broke down right now is more considered a class. There we go. So a class is more considered, you could just think of it as a blueprint. So in our problems, typically in our applications, we have to break down our problem like this. So we've basically provided a blueprint for all employees within our store. If we want to add in a new employee to our store, they'd have to go ahead and, well, we'd have to give information for each of these attributes, and then they could have these different operations performed with them. So just know that this in general is a blueprint. And with this blueprint, we could have different employees. So maybe you could have one for Sam. So say maybe someone named Sam, another one named Daniel. That is very horrible writing of Daniel. Maybe you have someone for Jessica. There we go. But each of these, again, they're their own little things. Let me actually use black for this. So these are each different people, but their data is created by using the class. So these would be different objects. One way to look at this is thinking of a factory. So different factories can have templates for how specific products are made. So again, you have your little factory. There we go. And whatever that factory makes is going to be considered a single object. So you have different, maybe they have boxes, maybe they make triangles or circles. But just know that in this factory, again, this is the class. What comes out of that factory is going to be different objects. So that may be a little confusing from how I was trying to define objects earlier. But again, some people use objects and classes interchangeably, but just know the difference. A class is the blueprint, and this is what we actually implement in Java. Objects is how we use that class. This will be a lot more easier to see. Again, if you're more visual with the programming, you'll see it when I show you how to code in just a second. Okay, so I'm going to take this over to Java, and we're going to go ahead and I'm going to point out a couple of things. So starting out with this Java program, week10.java, you'll notice that every time you want to create a new program, you have to create a new class. So every time you right click here, you go to new and you do class, and that creates this Java file. So every Java file is considered a single class. So you're thinking of it as a single entity. And up here, you notice that we always store code within public class, and then the name of the file. So in this case, public class week 10 is the name of this file. And know that yes, you've been pretty much creating classes all along. The only difference is, I'll tell you in a bit why this one has a main function, because notice not all classes have a main function. I'll discuss why in a moment, but I do want to show you how to, in this case, we're going to implement a class for employee. So again, we're going to create a template in which now we could use to represent different employees, so different data for employees. So right now we're just going to focus on template. To do that, I do need to create a new class. So we're not going to use this week 10. We're actually going to go ahead and let me right click on my default package. Again, some of you have already packages made, so just make sure you right click on the package itself, not SRC, the package. Go to new class. And then again, this class I want to represent employees. So I'm actually going to name this one employee. There we go. And we're not going to give it a public static void main. So you could actually leave that be. If you do get it, go ahead and delete it from the code itself. So remember, this is for the employee class. Let me go ahead and finish. Perfect. And now we have a public class employee. Notice it does not have a main function. Again, this is very important. So employee has no main function, and we want to make sure that it's level with our actual program that we're going to use later on. Okay, so we're in the employee class right now. And let me go ahead, let's go back here. Let me erase some things. All right, so I'm setting this up to create something that we call, oh, wrong pen. There we go. We're going to do something called a UML diagram. Now, UML stands for Unified Modeling Language, and this is used to create different class diagrams. Basically, what we did here, it's pretty much the same. It's just a lot more intricate when you're planning different applications. So remember how I emphasized on planning your programs, especially when it comes to larger applications, like here, if we wanted to do one for managing a store, we're going to have to go ahead and actually plan out what classes we want, so what kind of objects we're representing, and what goes in each class. So we did our breakdown here. Let's put it in a more in an actual UML format. So if you look in the notes, so remember I provide notes for the content within the readings. You'll see that it's pretty much like a box. So one, you have an employee, and then typically in this portion we will go ahead and put in the different attributes we want. So one of them is going to be the name. So this is again planning out that, hey, we want a variable name in here. This dash actually means, so this dash means that it's going to be private. I'll discuss what that means in a moment. Plus signs means that it will be public. So just like how the name indicates, you're saying that, hey, this information is private, so only kept to the code itself, or it's public for the rest of the code to use. So you have the name, and typically we do a colon and indicate the variable type. So in this case, this would be a string. There we go, and we do these for the rest of the attributes. So we have an ID. Let's just do this as lowercase ID. And maybe this will be some kind of integer. So we'll go ahead and say int. And we keep going down the line. So salary is going to be a double, colon, double. And notice I'm putting these attributes all as private with the minus sign. That's because the typical practice for putting the attributes for a class is to keep the attributes private. Okay, so that's going to be our salary, which is going to be a double. Then we have our position, which is going to be a string. Okay. Then once you have your attributes, you do more or less the same, but for your operations. So you're going to have an operation. Notice that this is going to be publicly used. So I'm putting a plus sign for changing name. So we're actually going to call this set name. Excuse my writing. Set name. And how we associate functions is by putting in those parentheses. So this, even though we have this line separating the two, this just further shows that, hey, this is an operation. This is a function we'll include with this class. So set name, and then you still have to give the return type for that function. So remember, functions have return types. We have to indicate the same, just like how we indicated the data types for each of the attributes. So set name is actually going to be void, because we're only doing something. We're only changing the name or giving name a value. Maybe instead of increasing the salary, we want to set the salary. So we're going to go ahead and say set salary. And this will be void too. And then we're going to have work. So a function called work, and maybe we'll have this be void as to, we'll just print something out like they blah 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 has worked. So this is how we set up a UML class diagram. This is for a single object. Well, not a single object, a single class. There we go. And again, it's shown as this way. You have the name for the class at the very top. You have the different attributes you're setting. So again, these will be represented as variables. So attributes turned into variables. And then down here are your operations related to the class. So I'm just going to call this up. And of course, you're going to implement these as functions. So this is your planning template for creating the class. Okay, so with this in mind, let's go ahead and let's go through the attributes first. So when it comes to setting attributes for your class, again, we don't have a main function, so do not put in a main function here. We're going to put everything just within these braces for the class itself. So since we know that the first one's going to be, if I actually do a side by side, there we go. So we know that we have an attribute called name, so it's going to be a string. So let's say string name. There we go. And yes, this is valid. We could keep it this way, but of course we said that wants to be private. So actually in front of the variable, we're going to say private string name. There we go. So when associating through this class, this means that, hey, name can only be accessed within this class. So within here and nowhere else. We're going to do the same for private, but int ID. There we go. We're going to do private, whoop, wrong spelling, private double salary, and then private string position. And there we go. You basically set up your attributes. Cool. Now, let's go ahead and set some of the operations. So let's call set name. Whoop, not call it, my bad. I forgot we're making a function. So remember, to create a function, we go ahead and we have to indicate the data type. So it's going to be a void. We give it the name set name. There we go. And remember, the plus sign means public. So in front of our header, we have to say public. There we go. So this is just generally setting up. We're going to do more with this, but down here it's going to be public void set salary. And then we're going to have public void work. All right. Now, one thing we do know is typically within this UML class, if you want to put in, let's say, parameters, so in the case of set name, we need to take in information to actually set the name. So you would put the parameters here very similarly. Instead, you would just do like the name of it, like maybe one of them is first name, so I'm going to call the F name. Then you do the colon and then the data type, so that this would be like a string. And then you would separate it by a comma, and you could say last name, so maybe this is last name, and same thing, string. So yes, if you want to get really intricate, you'd have to include those parameters as well. So now we know, okay, we have a string here, and it's going to be first name, and then this one is string last name. So I'm putting F name, L name. Let me do a lowercase n. This is a lowercase n. There we go. All right. And same thing here. We want to pass through something to set the new salary, so this has to be a double. Let's call this sal. And then work doesn't need anything. Actually here, let's go ahead and implement this function. So again, we just wanted to indicate like, hey, blah, blah, blah is working, so their name. So let's just go ahead and use system.out.println. And we're going to call the name. Actually up here, notice we don't want just a single name. We want the first name. And we want a last name. There we go. And you would indicate that within your UML class diagram. Remember, that's the main reason why you want to plan it, so you don't have to keep on making these different changes back and forth. So the benefits of planning your program out first and in depth. So in this case, we would say, we just want to say first name is working. Okay. So we'll discuss these other two functions later, but just know that we have the work. One thing I do want to point out is, okay, so when it comes to creating a class, typically you want to use something called a constructor. A constructor is basically how you set up the object that you're creating from the class. So think of it as you've gone to the factory, you see the blueprint, and you say, okay, maybe you have like a blueprint for, maybe it's like a car, a toy car. So the blueprint has all these different attributes. You go to the blueprint and you're indicating, okay, I want a blue car with this kind of model. In order to actually do that, so having to tell the blueprint, hey, I want to make this with this, we need a constructor. To create a constructor, it works very much like a function. So we're going to have public, but instead of giving a data type, you're actually going to call you're going to indicate the class name itself. There we go. So public employee, and we had to give parameters to this. So the different things we have to set for this employee to kind of indicate that, hey, we're creating this object. So basically that would be all of the major, you could say, required information for this entity. So we definitely know that we want to pass in the first name, the last name. So we're putting these as the parameters. You want the ID, we're going to put sal for short for salary, and then pos for position. And of course, let's go ahead and give them the data type. So this one's an int, this one's double, and this one's string. Perfect. So basically this function is going to go ahead and it's going to allow you to pass in information to set this up, and you actually have to write down the code to set up this class. So basically telling the program what goes to what. So to do that, you just say you get the attributes first name and you assign it the according value. So in this case it's first name equals f name, last name equals l name, ID equals ID. Notice that this gets a little weird because the argument is the same name as the attribute. So you're going to use something called this. So this, the actual word this with the dot used in front of a variable name is actually a reserved word which indicates, hey, when I call, in this case, if I call ID and I put this in front of it, it's referring to the one for this class. So the ID here. So when ID is called here, so the name ID, within this context, it thinks, okay, ID is this argument. This ID is for this class. So think of it that way. Usually it's good practice every time you want to use an attribute, you say this and then the attribute name, just to avoid any confusion with the program. Okay, so this first name equals the f name we passed in, this last name equals l name that we passed in, this ID equals the ID, and we'll do the same. This salary equals sal, this position equals pos. There we go. So again, this is our constructor, and let's go ahead and actually see how this works specifically. Okay, so we're going back to our week10.java, and this is actually what we're going to consider. I'm going to put this comment at the very top, but this is what we consider a driver class. Basically, a driver class is the one with the main function. So you could think of it as if you think of a car. So a car is an actual vehicle that if you don't have someone in it, it could be put to rest, but you could start it up and drive it. And by driving this car, you can have different things happen. One, you could make it move, and two, if you pick up other objects, you could have them move and do different things along with it. So just think of the driver as the one that is the main manager of your application. So this is the one that's actually getting things started. Again, your main function. Now, we want to, based on the employee class that we created, we want to create an object with this function. So let's go ahead and we could actually, so our employee in our week 10 is at the same level. So we could go ahead and create a new employee by saying employee new emp equals, and remember how we used that the new scanner system.in when it comes to the scanner class? Let's actually do that real quick. Okay, so I set up the scanner class. And remember, I mentioned scanner is a class. This is an object created as a tool for you to use the console or whichever medium you're using as an input. Notice that we have the new reserved word here, and then you get the name again. And notice here, this is using the constructor of the scanner. You're saying, hey, I want to create a new object that's a scanner. But again, system.in indicates the console. It's saying, hey, we're going to use this part to get in the input. So we're doing the similar thing. Instead, we're making an employee class, and we're going to say new employee. And you're going to use the constructor template here to pass in the arguments for the data you want to set to this employee. So in this case, we did have an employee called Bob, so let's go ahead, and the first name is Bob, comma, let's going to call this Burger. So last name Burger. So we have the first name, last name. The next is an ID, salary, and position. So let's give them an idea of 111. A salary, let's be, in this day and age, let's go 2050. And a position is, let's say, a cook. Close that off with a semicolon, and there we go. So now we have a new employee with the information Bob Burger, ID 11, given a salary of 2050, and he is a cook. And if you notice, if I want to use anything with Bob Burger, I could go ahead and call the function work from him. So just like how you use the scanner, you use the name stdin. So you have the stdin.next to get some values. Let me go ahead and comment this out. You'll do the same thing with your employee class. So this one's called new employee, and we're just going to call the function work. There we go. So again, we're still using that dot in between to indicate, hey, we're getting some kind of attribute or function related to the class. And let's go ahead and run this. There we go. And we could see Bob is working. If I change Bob's name here to Sarah, let's run this. Sarah is working. If you want to see all of the information of the employee, let's try something else. Let's do system.out.println. And again, I mentioned you could get different attributes by doing the dot. So let's go ahead and just line it out. Maybe you want to try to get the first name, last name, salary. So you do something like this. So new employee, first name. So use the name exactly. Oh, but notice it gives you a red. And if you hover over it, the error says the field employee first name is not visible. Now this is where we get to our private and public applications to the program. So again, private, if you set something to private within the class, that means it could only be used within this class. So notice we could set it, and we could even use it like how we did down here. Oh, let's do a good practice of this dot first name. There we go. Give it some time to adjust. There we go. So if I set the first name to public, notice that now the program's okay with it. So if I run it, it prints out Bob. Typically, this is not good practice to use. When it comes to programming, you want to keep the attributes to the class itself, just to prevent, let's say, other people from just randomly changing it, or at least the usage of these attributes to be limited. Oh. So anytime you do want to display something, I recommend creating a function for it specifically, just like how we did down here with printing it out. So you could do something called print info, and you could print out everything about this class according to how you would like to format it. So we could do this, like set it up as name. There we go. Let's not do that. There we go. So we have the first name, and then we could do the last name but with a space. And see, it's happy because we're doing it within this class. There we go. We want to put the ID, so we'll just do, let's replace all this. It'll be the ID. Nope, my bad. We're gonna do the salary. And for this, we're gonna put hourly. So let's just call this hourly pay. Salary. And then the position. And this will be the position. Okay, so let's just do a $sign here. I could format it. Remember, there's a way to format with the printf if you would like, but we're just going to leave it like this for now. And let's go ahead and go back to our driver class, and let's call information to see if everything's been stored properly. So remember, just use the name of the object you've created, and we're going to call this, we're going to call the print info. So now if we run this, Bob is working, and we printed out information about Bob, which you could see is the stuff that we stored in here. Bob Burger, ID 111, hourly pay of $20.50 per hour, and position as a cook. We could create more objects with this. So again, we could have a, let's have a Jessica. Let's have a Jessica Garcia with a different ID. Let's do 11123. Give her hourly pay of $25.50, and then maybe she's a waitress. There we go. And of course we have to give it a different name. So let's go ahead and say employee 2. This one's going to be employee 1, and of course if you change the names, you have to replace the rest. There we go. And let's not have Bob work right now. Let's just go ahead and print information for employee 1 and employee 2. So remember, you call the object in which you want to perform the function print info. There we go. So now if we run this, you see that now we have the same format, but one class is storing information for Bob Burger with the associated ID, salary, and position. The other is doing the same thing, but it's setting it up for Jessica Garcia, ID, hourly pay, position, waitress. So notice that now you could, instead of having a whole bunch of variables within this program for each person, even if you store all of that as arrays, that would be a lot of things to handle, and a lot of ways that it would be very confusing to try to implement. But in this way, you have a template which will do everything for you. You'll print it out, you have a function to have them work, and everything's just neat and orderly within a single object. So that's the wonderful thing about using classes and then creating objects out of those classes. Now if you want to, let's say, implement some functionality for this, maybe you don't want to print out the information, maybe you want to print it in a specific way, you could go ahead and create a function for that in relation to the class. So it could just grab that data you stored for it within with the constructor, and you could go ahead, implement it, call it here. Okay. So then that's for basic setting up the classes and creating objects, as well as calling operations from those objects. let's say maybe you made some kind of error implementing, in this case, the name itself. So one thing you can do is we have different functions that have specific uses within classes. You'll hear something called getter and setter functions. I'll discuss what these mean. So let's go over setter. Setter functions is also what we call mutators, which means that if you call these functions, it's going to change some attribute, some value attribute within your class or within the object. So in this case, set name means that we're going to set the name. So it's going to be this first name. We are setting to f name. This last name, we are setting to the last name pass through. So over here, let's focus on just Bob for now. So if we could print the information about Bob, maybe we spelled Bob's name incorrectly. Maybe it's actually some weird spelling of Bob. Maybe with, let's say, maybe he wants to be preferred as Bobby. So we'll go ahead and call this mutator. More specifically, this is known as a setter. And we'll go ahead and pass in the information. So instead of, so again, we're going to call set name. And he wants to be called Bobby. But he's still going to be called Burger. So now if we call this information again, you'll notice that it changes down here. So let's go ahead and run. There we go. So you see the first instance, employee 1, print info. We have what we set by default for this employee, Bob. So you have name, Bob Burger, ID, hourly pay, cook. But then we changed it, and it changed the value of the attributes within that object. So we changed it from Bob to Bobby, kept the last name the same, Burger. So now you have name, Bobby Burger, ID 111, hourly pay 20.5, position, cook. So anytime you want to set that kind of functionality, you need some kind of function to actually change these. This is why you want to keep the attributes private, so you can control how things can be affected. Like in the case of the ID, we want to set the ID, and that ID isn't going to change. So now we're not going to give a setter or a mutator for that. We're just going to go ahead, assign it, that's it. But things like maybe there's an issue with the name, or in this case that we want to update the salary, we could go ahead and do that. So you have the salary. Salary is also another form of mutator, but if we want to like increase it, maybe if you have a specific increment you want to do, you could go ahead and do that. But here we're just going to do this, that salary equals sal. So same thing. If you want to set the salary, let's go ahead, let's do employee 1 dot set salary. Give Bob a new salary. So maybe we're giving him a big increase, $50 an hour. And if we print that out, you see that it changes as well. So there we go. So we have the initial iteration here. Then we have when we use the set name to change the name. So now it's Bobby Burger. And then now we set the salary, and now he has $50 an hour. So that's for setting the salary. If you want to create one for the position, you do the same. You just have to create a whole separate function for set position. Now there's a different kind of function called getter functions, more formally known as accessors. And these are for, let's say, you don't want to print out everything as print info. Maybe you just want to get a specific part of this. This is where you could create the function to do so. So we want to make it public. And since we're returning something, you actually want to give it a data type. So we're going to say maybe we want to return the name, so a string. Call this get name. We don't need a parameter because all this is going to do is return this dot name. Or in this case, we want to format it as first name, give a space in between, and let's put in the last, this dot last name. Okay. So now if we use it, if we want to use it here, we could print, now we could use the system dot print line, system out print line. And again, we can't access the first name and last name directly because they're private, but we could say, since getName is a public function and it's returning a string, we could say employee1 dot getName. And again, it's a function, so you still need those parentheses. So now if we run this, there we go. Now you have, these were the different other iterations that we did before for print info, but down here, this is where we're printing out the name. So if you need to access it like that, you'd go ahead and do the get name. If you have to do something for salary, you do the same thing. You'd say the public return the value of the data type of the salary, so double, and then you'd return it. So that would look like this: public double get salary parentheses, and then you'd return this salary. All right. The rest of the functions down here is just what we call operations. So other operations other than mutator or accessor, which is related to this class. Okay, so this is what you will be doing for your project for a specific class I am asking you to create. And yes, you could create multiple classes to be associated with this. If we want to make one for, let's say, a product within the store, you could go ahead, again, create a new file, but for product, and give specific attributes and operations related to that. So those are the different things you will be doing. Later on, you will learn some other ways in which you could use this a lot more creatively and a lot more efficiently. So for instance, notice I was still making separate variables for each employee. So like employee 1, employee 2, so different objects. But notice that there actually is a way to create an array of objects. So you'll be seeing that in the next topics we'll go over for the following weeks. Okay. So those are things you can look forward to, but just know this is the basic thing that you will be doing for this assignment. You'll be going ahead and creating the class, so creating the template, and then you'll be creating objects out of the class. So giving some kind of data and then doing something with that kind of data operations within your driver class. I will leave it at that. Again, if you do need assistance with this, please make sure you're reaching out to me. Again, we'll be working a lot with object-oriented programming in the next coming weeks. So just know that you will need the basics down, and every lecture is going to build on top of each other. So if you are struggling in any way, reach out to me. We could go over in student hours. I could go over with you over message, or we could set a separate Zoom meeting. All right, take care.